Alright, yesterday we were talking about all the properties of rectangles, right? And we said rectangles are parallelograms. So they have all 5 of the properties of parallelograms that we already talked about, plus 2 more. Right? All 4 angles are right angles, and the diagonals are congruent. So then we were looking through all of these problems down below, and I think we got about halfway through number 7. Okay, because 7 was a quadratic that we needed a little refresher on how to solve. So we had, let's see, this angle was 10x, this angle was 4x squared minus 6, and those 2 angles we said would be equal to each other, because if the diagonals of a rectangle are congruent, this would form an isosceles triangle. So we said 4x squared minus 6 would equal 10x. Then we would subtract that 10x over. 4x squared minus 10x minus 6 equals 0. And then we started talking about factoring. Right? To solve this, we would need to factor. So, factoring means we're multiplying our a and our c values. So 4 times negative 6 was negative 24. Our b value down here. So we're looking for 2 numbers that multiply to negative 24 that adds to negative 10. And we came up with positive 2 and negative 12 for that yesterday. So we said what that means is I'm going to take those 2 numbers and split up the negative 10x. So that'll become plus 2x minus 12x. And so those negative 10x just becomes positive 2x minus 12x, and then we have to factor by grouping. So that means I group the first 2 terms, group the second 2 terms, and look for a GCF. So we took out a 2x out of this first set, and we were left with 2x plus 1, and then we took a negative 6 out of this second set, we were left with 2x plus 1. I think that's about where we got to. Okay. So now, what this means, since both of these values, both of these expressions are the same, I can factor those out. Okay. This whole thing here, the 2x times 2x plus 1, we think of as one term. So I can factor 2x plus 1 out of that term. Same thing here. The negative 6 times 2x plus 1 is one term. So I can factor 2x plus 1 out of that as well. So if I factor 2x plus 1 out of both of those things, what I'm left with is 2x minus 6. Okay, and we have our quadratic factored now. To solve that, I take each of these factors individually and set them equal to 0. So I'm going to have 2x plus 1 equals 0. 2x minus 6 equals 0. Okay, the reason for that, okay, we want this whole thing to equal 0. So if I'm multiplying by 0, right, if either one of these is equal to 0, the whole thing will equal 0. So that's why we want to set each one individually equal to 0. So when we solve this first one, we'll get negative 1/2. And the second one, we will get positive 3. So we have 2 answers, right? How do I know, because we're still not done, right? The question says find the measure of angle ACB. How do I know which one is going to be right? Well, they're both real numbers, yeah, because it's positive. Yeah. Yeah, so if, right off the bat, I mean, hopefully we can tell that if we plug negative 1/2 in, we'll end up with a negative value. But if we can't tell that right off the bat, we can just plug both of them in and see which one makes sense. Okay? If I plug 3 in, measure of angle ACB will be 4 times 3 squared minus 6. Okay. Make sure that we use order of operations. Order of operations says that we square the 3 first. first before we do multiplication. So 3 squared is 9. 9 times 4 is 36. 36 minus 6 is 30. Okay. If we would have plugged negative 1/2 in, we would end up with a negative value, which doesn't make sense when we're talking about an angle measure. Okay. So this was a fairly long, complicated problem, right? Because we had to solve a quadratic, and I know you guys haven't solved quadratics for probably about a year. Okay. But we okay with that one? Sure. Kind of. Okay. Now the last one was also, I think, a little bit tricky. Okay. So on this one, in our diagram, we were talking about AB and BC, and we want to find BD. So first, we're given that AB is 6y, and we're given that BC is 8y. My goal then is to find BD, but one of the properties in rectangles is that the diagonals are congruent. So if I find AC, that'll be the same as BD. So what we actually have here, since this is a rectangle, we know this is a right angle. I've got a right triangle. I can use the Pythagorean theorem to find the third side here. Again, something that you haven't seen this year yet. Okay, we will dive into the Pythagorean theorem in detail later in the year, but you have seen the Pythagorean theorem before, right? So, to use the Pythagorean theorem, remember we're thinking the legs of our right triangle are A and B, and the hypotenuse is C. And that formula is A squared plus B squared equals C squared. So, I know the two legs are 6y and 8y. I want to solve for C, the hypotenuse. So I'm going to set this up as 6y squared plus 8y squared equals C squared. Now, when we're squaring these terms, okay, we have to make sure that we're squaring both pieces. Okay, this is an algebra idea, properties of exponents. 6y to the second power would be 6 squared times y squared. Right? So this would actually be 36y squared. Same thing for the 8y. We have to square both pieces here. So this would be 64y squared. So now these are like terms. I can add these together. 36y squared and 64y squared would be 100y squared. That's a lot of y squareds. Okay. So now, the only thing left to do to get c by itself would be what? How would I undo this square? Square root. Okay. So take the square root of both sides here. And when I do that, just like when we squared up here, when I take the square root, I'm taking the square root of both pieces. So the square root of 100 is 10. The square root of y squared is y. So c is y squared. So we found that AC was, did I say y squared? I think I did. We found that AC was 10y. Therefore, BD is also 10y, because the diagonals in a rectangle are congruent. Okay? So these last two were a little more challenging. Right? Still using our new ideas of properties of rectangles, but pulling some of the more complicated ideas from algebra that you may have forgotten. Okay? Other questions on any of these? All right, and let's flip over to the back. And let's talk about proving that a figure is a rectangle on a coordinate plane. Okay, so if you remember, we talked about proving that something is a parallelogram on a coordinate plane using a couple of different methods. One was using slope and finding that opposite sides are parallel, or opposite sides have the same slope. The other way for a parallelogram was using the distance formula and showing that opposite sides are congruent. We can do similar things for a rectangle. Okay? We would just have to take it one step further. Okay? So we know a parallelogram, opposite sides are parallel. So that's going to be the same thing in a rectangle. Opposite sides will be parallel, but there's one more thing. We're talking about slope. If we know all four angles are right angles, not only will opposite sides have the same slope, consecutive sides will be perpendicular. Okay? So, to prove that something is a rectangle, we should have to show that opposite sides are parallel and consecutive sides are perpendicular. Okay? Consecutive means like right next to each other. So like AD and BC are opposite sides, but AD and AB are consecutive sides.
Angle A is consecutive side of B.
So if you're talking about angles, angles A and B are consecutive angles because they're next to each other. Angles A and C would be opposite angles. But if we're talking about sides, we could say side AD and side BC are opposite sides, and side AD and side AB are consecutive sides. Yeah. Okay, so using slope to prove that something is a rectangle, we would, just like a parallelogram, we would want to find the slope of all four sides. So let's take a minute and do that here. Okay, for AB, we can write out the slope formula if we want. If you know the slope formula and can just plug things in, that's perfectly fine. You don't have to write out the formula, but I'll write out the formula for the first one here. Our slope formula is x2 minus x1 over, oops, I did that backwards, y2 minus y1 over x2 minus x1. There we go. So we plug in our values for A and B. Y2 minus Y1 will be 3 minus 0 over X2 minus X1, negative 2 minus negative 3. So that'll be 3 over negative 2 plus 3 will be 1. So the slope of AB is 3 over 1. So let's take a minute here, and you guys find the slope of the other three sides of this potential rectangle. And we'll see whether it is a rectangle or not by comparing the slopes. How many times what? Never use the justification. It looks like you gotta prove to me that it is. So the air test doesn't have any questions where you have to like write out an explanation. So the way that something like this could be presented on the air test would be like maybe like the slope of BC and AD is 3. What would the slope of AB and CD have to be for this to be a rectangle? Like that kind of thing. No. Not the same.
No, like not the same.
So that they would have to be the same for it to be a parallelogram, but we'd have to go one step further to make it a rectangle. And say, yeah, they would have to have opposite reciprocal slopes from the ones that we know. That would be a rectangle. Yeah. If two lines are perpendicular, their slopes are opposite reciprocals.
Perpendicular to like A, B, or perpendicular to B and C.
Yeah, AB would have to be perpendicular to BC.
That makes sense. That part.
About to have another long weekend.
I know I already off.
Yes.
Yeah, I'm not gonna be here Friday.
Oh.
I just really want
Wait, Mr. President, I have a question.
Of our contract. I've been 8 hours.
So, like, I was here Friday, Monday, and then how do I keep it?
I mean, there's several talks here, but I mean, technically Thursday is the official makeup.
Okay, that's what I'm.
But like, I mean, I'm sure you can go in there and study hall or something. Like, you talk to your
Are they supposed to
First thing on the science server, taking trigger. Yeah, I'm taking super mega math.
Alright, did we get that AB and CD both had a slope of 3? And AD and BC both had a slope of negative 1/3? Okay, so since opposite sides have the same slope, that makes it a parallelogram. Since consecutive sides have opposite reciprocal slopes, that's what takes it one step further and makes it a rectangle. Okay. Questions on this one so far? Alright, so we've got a second way to show that a figure is a parallelogram. Let's see those points. This way is using the distance formula. So for a parallelogram, remember we found the length of opposite sides. So well, if opposite sides are congruent, they have the same length, then it's a parallelogram. We can take that one step further then and say, well, if I find all 4 opposite sides and show it's a parallelogram, and also show that diagonals have the same length, then I can say it's a rectangle. Okay, so this one requires a little bit more work, okay, because we have to find 6 lengths. We would have to find all 4 sides to first prove it's a parallelogram, and then find the lengths of the diagonals to take it one step further and prove it's a rectangle. The slope one, if you have a choice, is probably a little easier, a little less work. Just to show that we could use the different properties. So, remember the distance formula, so you can write it up here, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So, if I want to find the length of AB, I'm just plugging that in as negative 3 minus negative 2 squared plus, bless you, 0 minus 3 squared. Okay. Now, before, or we've kind of done this by hand and gotten an exact answer, you know, like the square root of 10 or something like that. We can just plug this whole thing into a calculator as is to get a decimal approximation. Right? So, I mean, you guys know where the square root button is on the calculator, and parentheses, and the square button, all all that jazz. Okay, we can plug this in exactly as is. If you're more comfortable doing it by hand, that's perfectly fine. Okay, but we can plug this whole thing in at once. If we do that, we would get square root of 10.
Yeah.
Right? I just randomly said square root of 10. Grade 7 magic. It is.
I work first period too, so it's not like you did before.
Right. Sure.
Right here, like, skull.
Your brain's small.
Yeah, but like this is.
Alright, so let's take a minute here and find the lengths of all these sides. Prove that this is first a parallelogram. And then go one step further and prove it's a rectangle.
Yeah.
I mean, this is a proof.
Yeah, but it's not like, wait, this. Yeah, you don't have to like. It's actually math. It's not like words.
That's the logic.
Okay. No one asked you.
But you did.
You know, you have to ask Mississippi workers to sharpen the pencil in Spanish. Yeah. Congrats.
You gave me 6 points. Thank you.
What? Oh, are we simplifying radicals?
For this purpose, no, we don't have to. Because all we're doing is seeing if they're the same.
That's what I was wondering.
First, you are useless. Useless.
Oh, I see. Do it. I lost your
25 plus 36 is 60.
Well, I just did the math wrong. I'm all yeah, but 3 times 2 is 6, okay? It's the exam. I don't know if it's the last night.
What'd you say?
Well,
I then I'll get
Multiplication is worse because it Adding it up.
And you still have pictures that we.
I'm lecturing today. I'm lecturing today. All right, did we get these values for the sides and then the diagonals? Almost. Okay, so I simplified, but for these purposes, we don't have to simplify because all we're doing is comparing the lengths. So BC and AD are both the square root of 40. AB and CD are both the square root of 10. So that makes it a parallelogram since opposite sides are congruent. And then what makes it a rectangle is that diagonals are congruent as well. All right. Any questions at all on rectangles so far? All right, and that's it for